Listen, by now, you should have made some effort over the past days to try and understand what the general solution is all about, even on your own. You read, you have got access to videos, not even the ones that I made, even others as well. All right, so 1a, we have got an equation there for tan, okay? The question says, find the general solution of each of the following equations. So, tan has got one general solution. So if you write your equation, tan theta equal to minus 2,5. Then last year you were taught how to solve a trigonometric equation like this. The grade 10 teacher taught you. So this becomes theta equal to shift tan of minus 2,5. Now last year, so that when I'm doing it, you're also doing it as well. Right, so shift tan, right, of minus 2,5. It will give you that is the answer. Now that answer is your reference angle. It's called the reference angle. The answer that you get from the calculator is called the reference angle. Now this angle here, it's a negative angle. Okay? But since we just want to get a general formula, we are going to write it as it is. We'll round it off to 2 decimal places. Okay. Last year, you could not write this as your answer because normally your angles were between 0 and 90 degrees. Last year, you could not write that as your answer. Because in grade 10, you concentrate on solving trig equations that give you positive angles between 0 and 90 degrees. So what that means is, we could not give you a negative ratio here because you were in grade 10, but you are in grade 11 now. So we can give you a ratio that's negative. And you can get negative angles as your reference angles. So that's minus 60. So now what I wrote here now, I need to add k times 180 degrees. The reason why I have to add this k times 180 is because it helps me to get all the possible solutions of that trig equation. Okay, this k times 180, it is added so that I can be able to get all the possible solutions. Tan itself has got a graph which you drew last year. There is a connection between trigonometric graphs, trig equations. You cannot understand trig graphs fully without understanding trig equations. So last year you drew the graph of tan. You are only drawing it between 0 and 360 degrees. But it can be drawn on the negative side of the Cartesian plane. It can be drawn beyond 360 degrees. So this K180 here, it caters for all the possible solutions of the trig equation from minus infinity up to positive infinity. Okay? And the K must be an integer. You were taught integers in grade 8, grade 9, grade 10. Okay? So that Z there, it represents integers. By integer, we say K can be 0, which was the case for you guys in grade 10. K was 0. Okay? That's why when you're solving, you're only getting the reference angle here using a positive ratio, and your answers that you get were between 0 and 90 degrees. The K was 0 in grade 10. Okay? We could not introduce you to such advanced trig because we were in grade 10. Now we're in grade 11. So you have been introduced to that. You need to know that last year, this part here, it was 0. K was equal to 0. So K times 180 gives you 0. So the equation was only this part only here. And your ratio inside the bracket was a positive ratio. That's why you were getting angles between 0 and 90 degrees. Right? So, from here now, we got the answer there. It's here. So if I round this off, minus 68,2. Okay, that's my, so this will be minus 68,20 degrees plus K times 180 degrees, where K is an element of Z. When you are writing this part here is very important. Okay, we normally allocate a mark for writing K is an integer. Yes.
So, do you have to keep writing the K is an integer, or
Yes.
or is it sufficient to just write it in the first place?
You have to keep on writing. All right. Now, what I have written here is this, and this is the answer. And this answer here is called the general solution. By word general, it means it's just a formula that you can use to determine all the solutions. Okay? This is the general solution of this trigonometric equation. If you want to find values of theta, say between minus 360 and 360 degrees, you start substituting this k. You used what is called trial and error. You substitute, say, k equal to 0. Then you get a value for theta. K equal to 1, k equal to minus 1, k equal to 2, k equal to minus 2, k equal to 3, k equal to minus 3. You oscillate. Okay? Right? And this is called the general solution. This formula here. For what? For these two equations. You can use this trigonometric equation to find all the possible values of theta that can satisfy that equation. All right? Yes. It will depend on the interval you are given for theta. Okay? That's when you start substituting the k. Don't worry, we'll do an example where we are given a restriction for the values of theta. But first, you need to understand the basic concept of the general solution. What is it for? Right? So that's the first one. Then B, we have got cos theta equal to 0.4. Cos theta equal to 0.4. Your control test has got two questions on trig equation, and you have to know how to answer them. Otherwise, you come out of the test and say it was very difficult. All right. Here, our ratio, this is the ratio. This 0.4 here, it's a positive ratio. Okay? Which means between 0 and 360, there are two answers that can satisfy this equation. One is in the first quadrant, the other one is in the fourth quadrant. Because cos is positive in the first and the fourth quadrant. Alright? So, I'll say theta. Now, for cos, there are two general solutions. Two. Okay? And as I told you last week, we write them as plus minus shift cosine of 0.4, because that's the ratio, plus k times 360 degrees, where k is an integer. Now that we are dealing with cos, we don't put 180 here. Okay? The period of a cosine graph is 360 degrees. The period of a sine graph is 360 degrees. The period of a tan graph is 180 degrees. So for tan, we use k 180, k times 180. For cos, we use k times 360 degrees. For sine, we use k times 360 degrees. And last week, I spent a whole lesson talking about the fact that tan, cos, and sine, they are periodic, which means they repeat themselves up to infinity. Okay, so here we have two general solutions. Yes.
So sine also k plus
Yes, sine and cos are actually the same. if I taught you last year, I told you that the graph of cos is actually the graph of sine. But you move the graph of sine by 90 degrees to the left, then you get the graph of cos. Cos and sine are related. If you didn't know that, you need to know that from now on. Then you bring in the calculator. That's now. So I'll write my plus or minus, then go to the calculator. And you're supposed to be doing what I'm doing as well. If I do it, you do it. Shift cosine 0.4. The angle that you get, which is a reference angle, is 66.42 to 2 decimal places. 66.42 degrees. So I'll write here 66.42 degrees plus k times 360, where k is an element of z. And this is the answer. It's just a formula that you can use to determine all the possible solutions of that trigonometric equation. Last year, this part was equal to 0 for you guys. Last year, this part here, it was equal to 0 because k was 0. We're only dealing with answers in the first quadrant. And here, where you've got plus or minus, you only took the plus, you didn't take the minus. But the minus gives you an answer that's in the fourth quadrant. Okay? Yes?
So cost is going to be a plus and a minus.
Yes, because cost is positive in the first and the fourth quadrant. If you take the positive, you put k equal to 0, your answer will be 66.42 degrees. If you put k equal to 1, you take the negative here, you get an answer that's in the fourth quadrant.
So let's say the reference angle is F or minus 8.
Well, if the reference angle is negative, the plus or minus 2 remains. Because if I put a negative here, right, like that, this negative here and that negative give you a positive. The positive and that negative there will give you a negative. So the plus or minus will always remain. Whether you have a positive angle or a negative angle to remain, it's always a plus.
Sir, I don't think that we have a minus 15.
It has to do with the quadrants. Cos is positive in the first and the what? And the fourth quadrant. So if you get a positive ratio, right, there are two reference angles. One is in the first quadrant, the other one is in the what? Fourth quadrant. Are you following what I'm saying? If you get, okay, look here. Let's say you get a negative reference angle. If you have got plus or minus, then you get a negative angle, say minus 30 degrees, like this, right? Are you aware that if I take the positive here, multiplied by the minus 30, I'll get a minus 30. If I take the negative here and multiply by the negative 30, I'll get a positive what? 30. Which means in the end, this part here will always be a plus and a minus because of the quadrants. Yes.
What quadrant is cost?
Yes.
Like that, we leave it as that or we solve further?
Sorry?
Like that, we leave it as that or we solve further?
Oh, you leave it like that. This is your answer. We are going to do questions where you need to get exact values of theta.
If you get it that right, I don't know.
Okay, on what basis did you get the exact value? Because you must have a restriction You must have a restriction or an interval for the values of theta. It's not given if you go to the original question. Is there any restriction about the values of theta? It's not there. The question, okay, look, Joven. The question says determine the general what? Solution. It's not saying find the values of theta. No. It's not saying determine the values of theta. That's not what the question is saying. The general solution is a general formula. It's a formula. Alright, boys and girls, listen carefully. Listen carefully. Hey, can you pay attention? Pay attention. Don't get confused there. The general solution is a formula. Okay? It is a formula that you can use to determine all the possible solutions for theta. We are not finding theta or rather values of theta. We are finding a formula that we can use to determine all the values of theta. That formula is called the general solution. Later, when you start substituting k equal to 0, k equal to -1, k equal to 1, that's when you find exact values of theta. Here we are just finding a formula that we can use to determine all the possible solutions.
So, before
All right.
so you keep go back. So you said tan is negative because it's and you see your tan is -2, like it's negative in the second and the fourth quadrant.
Yeah.
So that's where the negative comes in.
Okay.
It's negative theta.
Okay. Look here. Don't confuse my explanation for cos and tan. Don't confuse the explanation. For tan has got a graph. Okay? The graph is a period of 180 degrees, which means it repeats itself after every 180 degrees.
Okay.
For cosine, its period is 360 degrees, which means it repeats itself after every 360 degrees. Okay?
Yeah.
Tan now is unique because the period is not 360. Okay? That's why we only have one general solution. Because its period is not a full revolution, it's a half of a revolution. Okay? That's why tan has got one general solution. Because one full tan curve, last year when you were doing the graph, I cannot teach trig equations without bringing in the graph, because there is a connection. Okay? That's why after this topic on trig equations, we move on to grade 11 trigonometric graphs. Because you need the concept of trig equation, and the two, they are connected. Trig equation, trig graphs, they are connected. You cannot understand trig graphs without trig equation, and you cannot understand the trig equation without the trig graphs. The two are connected. Alright, so here, if I put, okay, well, let me put 9 there, then you can have 180. When you were sketching the graph last year, if I sketch from 0, it would go like this, right? And from here, it will go like that, right? That's how you're sketching it, right? And then, if you want, you can extend. If you draw another line here, you can extend, that you can have a full. If this is 90, this becomes 270 degrees. So it will go like that. Okay, you have an asymptote there. The graph of tan is unique. If I told you last year, I told you that. Okay, it is unique. So let's say you have got a value for y here. The value for y will be the ratio, right? If you have got -2.5 here, if you sketch the graph, say from 0 to 360 degrees, let's say there's 360 there, you need to have another half somewhere here that goes like that. that half and this half here, they ended up making one full curve. So when you draw, let me use a different color. But I'm just worried that I'm speaking Greek here. You have 2 points on the graph where you can get a value for theta there, another value for theta there. For the same value of y, you get 2 values for what? For x. One value of y gives you 2 values of x. Okay? We can exchange that to negative values. The same value of y here will give you more values of x. If you carry on beyond 360, going that way, the same value of what? Of y, it will give you more values of x.
But we don't stop the waste.
That's where I said, for trig equations now, you'll be given a restriction as to from what value of theta to what value of theta you want. Okay? So, yes. So the general solution now, it is just a formula that helps you to find all those values from the negative side towards the positive side. Okay? Then, when you get a question which is very specific about theta, it will say, determine theta, say, between minus 360 and 360 degrees. Then you start substituting the k now to determine all the possible solutions. Okay, I've tried to explain it. All right, let me move on. I've tried. If you didn't understand what I said, find someone who can explain it better. All right, find theta equal to minus 0.12. Sine theta equal to minus 0.12. All right. Now, sine has got 2 general solutions. 2. Okay? Generally, it's one in the first quadrant, the other one in the second quadrant, because sine is positive in the first and the second quadrant. And boys and girls, when I first introduced the grade 11 trick, right, I told you that knowledge of quadrants is extremely important. By now, you should have mastered the concept of quadrants. And as I'm teaching now, there's some of you, your body language, you are here physically, but you are not even listening to what I'm saying. Right? Theta, unfortunately, I didn't choose the subject for anybody. Shift sign of minus 0.12. All right? First, we are going to get a reference angle here. That reference angle, we add it to k times 360 degrees so that we can get all the possible values. Whatever reference angle we are going to get here, we are going to subtract that angle from 180 degrees. And we get a second general solution. So if I bring my calculator, it will be shift sine of minus 0.12. So you get negative 6.9. So it will be theta equal to negative 6.89. Negative 6.89 degrees plus k times 360 degrees, where k is an integer. This angle here, that's the reference angle. Okay? The angle that you get from your calculator, that angle is called the reference angle. For sine now, we don't stop here. This is the first answer, by the way. This is the first answer that I got here. Alright? For sine, we don't stop here. We have a second general solution. That second general solution, we get it by subtracting the reference angle from 180 degrees. Okay? Which is what I told you last day. Okay, so this is the first time. I'm not done. The second answer, you say, or, okay, let me write it here, or you say theta is equal to 180 degrees minus this reference angle here. So minus minus 6,89 degrees plus k times 360 degrees, where k is an integer. Eventually, you get your theta as, you just have to add these two because there's a minus here and that minus gives you a plus. So you get 186,89 degrees plus k times 360 degrees, where k is an integer. Then I've got the second one. So two general solutions.
And 180.
Just because sin is sin is positive in 6 points.
Yes.
So we had 180.
Always, when you find the general solution for sine, you must get two answers. For both sine and cos.
So we didn't get the second answer.
This plus or minus here, it means there are two.
So how can we do with the same way as a car?
Well, look here. Sine is positive first and second quadrant. Cos is positive first and fourth quadrant. Do you expect to have the same formula then?
What is the 180 minus?
Because sine is positive in the second quadrant. So by subtracting the reference angle from 180, you are catering for the second quadrant. Yeah, you're trying to find another angle.
So that 180 doesn't change. Always subtract by
You always subtract the acute reference angle
180. Always.
from 180.
Or from 180.
Yeah,
Always.
always, yes.
This is 180. No, but see the answer is 186.
So, okay, look here. This angle here. Do you see that our ratio is negative? Do you see that our ratio is what? Negative. Between 0 and 360 degrees, in which quadrant is sine negative? The third and what? Fourth. Do you agree with me that minus 6,89 is in the fourth quadrant?
Yes.
Do you agree with me that 186 is in the third quadrant? Yes. Take this 186,89, put it where there's theta there. Try it now. Try it now. If you are serious. Okay. Because I feel like some of you are not serious about the subject. Put the theta 186,89 here. You should get minus 0,12.
Yes.
Put the minus 6,89 where there's theta, you get minus 0,12. You see, with trig equations, your answers cannot lie because you can prove that they are correct.
So for cos, you don't need to do the second one, you just need to do the first one.
By, you see, okay, Chanda, by now I hope you know that this means we have got two. It's like, for example, if I ask you to find the square root, if I say find the square root of, say, 25, if you get an equation like this, x is equal to the square root of 25 plus or minus square root of 25. You write this as plus or minus 5. What does this mean? How many values of x? 2. That's the same thing then.
Like for every cos equation.
Yes. Yes. Last week on Thursday, when I wrote this, I don't know whether you went over your notes or what. Right? When I wrote it, check what I wrote here. I wrote A and B, then I combined the two.
Yeah.
Okay? This means there are two general solutions for cos, but they can be written as one formula, but in that formula it's a 2-in-1. Alright, so let me move on to D. Cos that. Now this is also a great term trig equation, by the way. Cos theta cos theta plus 10 degrees. Right, that's another example that I'm supposed to do together. So I hope I will. So D, we have cos theta plus 10 degrees is equal to minus 0.67. It's equal to minus 0.67. That's a ratio, right? Now, this one here, you just take the cos, you don't touch the theta plus 10 degrees. So it becomes theta plus 10 degrees is equal to plus or minus shift cosine of minus 0.67, right, plus k times 360, where k is an element of integers. Again, I want to warn you, the general solution are not provided on the formula sheet. So we have to memorize them. Okay? The general solution, the formula, the 5 are not provided on the formula sheet. Right? So here, we want to find the reference angle here. That's why I put the plus or minus. And I'll explain why we put that plus or minus. Right? Now this one here is slightly more complex because we have got this plus 10 degrees. So we still need to get our reference angle. Right? So I'll bring in the calculator, shift cos of minus 0.67. Right? You end up getting 132.07 degrees. Okay? 132. Now, the reason why we are getting 132 is because we have a negative ratio. The angle 132 is in the second quadrant, but it has a corresponding sister or brother that's in the third quadrant. So, the positive here, it caters for this angle. The negative, it caters for the one in the third quadrant. Yes. Because cos is negative in the second and what? And the third quadrant. Right? So it's 132. So it will be theta plus 10 degrees is equal to plus or minus 132.007. Right? 0.07 degrees plus k times 360 degrees, where k is an integer. Right? Just to remind you, this is the reference angle. We get that from the calculator. Right? If you want to find the one in the third quadrant, we put k equal to 1 here, we take the negative here. We get the angle in the the angle in the third quadrant.
What about the plus 10, sir? You leave it.
No, I'm not done yet. Remember, we need to solve for what? Theta. So from here now, we say theta is equal to, since we have got a plus or minus there, right? If I take this 10 here, it becomes negative. Am I right? So we end up having plus or minus 132.07 degrees minus 10 degrees plus k times 360, where k is an integer. Remember, because of this plus or minus, we have got two values there, okay? Because of that plus or minus. So let me take the positive and subtract 10 from it. Okay? In this case now, it will be better to split this equation into two. So I'm going to split it up because of that plus or minus. So I'll say therefore, if I take the positive first, if I take the positive 132, I'll get 132.07 minus 10, I'll get 122.07 plus k times 360 degrees, where k is an integer. That's the first one. Okay, the way that actually you have to do this question here is slightly different from the one where you only have theta. Here you've got that theta plus 10. So you have to split this up into two, and then you get your two general solutions. Yes.
Why is it negative?
Because I took the positive 132.07.
So But you took the positive, so does that mean that you have a choice to keep the negative as well?
Yes, I'm going to take the negative as well.
Okay.
In the end, I still have to get what? Two answers in the end. Okay, so I got the first one. Then the second one, I'll take the negative here. The negative of the reference angle. So it will be theta equal minus 132,07 minus 10. That will give me minus 142,07 plus k times 360 degrees, where k is an integer. So these two are the answers. These two. They are the general solutions of that trigonometric equation. You can use both of them to find all the solutions, all of them. Okay, if you are given a specific interval, you can use them to determine all the possible values of theta within that interval.
So, where I still be correct, I just said plus minus 122.07.
No, you can't do that. You can't do that because, well, if you want, you can say that yes, you can. Okay, it's correct. You can also say plus or minus 122.07. But you see now, if you say plus or minus 1, you only get this one here, but you won't be able to get minus 142. That's the problem. That's why for this question here, it will be better to split it up into two. Okay? Because in the end, you have to get two answers. So you can't write as plus or minus 122.07. You can't. You have to split it up because this minus 10 here, it changes things. I hope you are aware that this minus, this plus 10, it represents like a shift, a horizontal shift. Okay, because of that shift now, you have to determine your general solution separately. Okay. Yes.
How did we get negative 1
Okay. You see here, initially I took the positive, right? The positive of the reference angle, which is it will be 132.07. Then I subtracted 10 and I got this. Right? Then later I also catered for the negative of the reference angle. So negative 132.07 minus 10 to give you minus 142. If I were to ask you, in which quadrant is minus 142? Third quadrant. Okay? It's in the third quadrant. In which quadrant is 122? Second. And cos is what? Is negative. Second, third quadrant.
So you just stop there. That's the answer.
Yes. It's a general solution. Alright. Alright, then find 2 theta equal to that. So I hope I'll finish this one here before the and if we have sine 2 theta equal to 0.522. So this one becomes 2 theta is equal to shift sine of 0.522 plus k times 360, where k is an integer. Then you bring the calculator. So it will be shift sine 0.522. Right, you get a positive angle that's 31.47. So this becomes 31.47 degrees plus k times 360 degrees, where k is an integer. Now I want you to look carefully as I do this one now. This one is slightly different with the previous one that I did for sine, because the theta is multiplied by 2. So what you do, you divide each term by 2. So this becomes 2 theta over 2 is equal to 31,47 degrees over 2 plus k times 360 degrees over 2, where k is an integer. So this will give you theta equal to, if I divide that by 2, I get 15,73. So 15,73 plus k times 180 degrees, where k is an integer. Now, to get the second one, I have to subtract this reference angle from 180 degrees. So I'll say, or 2 theta is equal to 180 degrees minus 31,47 degrees plus k times 360 degrees, where k is an integer. Your first answer is that one, right? Then if I simplify this, 31,47, so it will be 180 minus 31,47. So that will give me 148,53. So I'll get 2 theta equal to 148,53 degrees plus k times 360, where k is an integer. Then from here, we divide each term by 2. So we divide that by 2, we will get, divide that by 2, you will get 37,13. So the final answer is going to be theta equal to okay, I'm rushing now. But when I divided this by 2, okay, it will be 148,53 divided by 2, you get 74,2. So it will be 74,2 plus k times 180. Okay, that will be the second answer.